Hi, this is an introduction to projectile motion. This topic is a little complicated, so we'll have multiple videos. I want to just start generally though. For projectile motion, this is just any object in the air. And in fact, free fall, just dropping something, is really just a form of projectile motion, but a simplified form of projectile motion, because you're only looking at vertical motion and not horizontal motion. With many projectiles, you're looking at both vertical and horizontal. And the tricky thing is that the forces and the physics are totally different in vertical and horizontal, and you have to treat them completely differently. They are related a little bit, but you got to treat them differently. Couple things to keep in mind also. For an object in the air, the only force is gravity, aka the object's weight, F sub g, which is equal to mg. And it's always there. So it doesn't matter where you go, you're always going to have, no matter where you are in your path, the force of weight pulling down on you, the force of Earth's gravity. The acceleration we've talked about as well is also 9.8 meters per second squared. But directions become important. So the force is always acting down, and acceleration is 9.8 meters per second squared down. But as I said, you have to treat vertically and horizontally the forces a little bit differently. So let's think about this vertically and horizontally. You don't always need to make these tables, but it never hurts. You could have a vertical distance. I'm going to call that distance x. You can have an initial speed, you can have a final speed, you can have an acceleration, and you can have a time. And we know that the acceleration is always negative 9.8 meters per second squared. That's always the case for any projectile object. Horizontally, you might travel a certain distance. I'll say y. You might have an initial speed. You might have a final speed. You might have a time. And the only thing that connects these two, the only thing, is time. So the time is the same for both dimensions. Time travels the same horizontally and vertically. But one of them is a balanced situation where your acceleration is 0 horizontally, and vertically it's unbalanced because you have a downward acceleration. So that means your initial and your final speeds are the same, because this is a constant speed problem, horizontally, but not vertically. And in fact, if you look at dropped objects are just like vertical if you ignore horizontal altogether, because your initial velocity would be 0, so your final velocity would be 0, and your distance traveled would be 0. The only thing you'd be doing is counting time. There's no point to that. Let's think a little bit more about this. So let's see the path of a projectile. The path could be a parabola. It's always going to be a parabola. And no matter where you are in this path, your acceleration is downward. Where no matter where you are in this path, your velocity, your force is downward. And at all points, acceleration is equal to negative 9.8 meters per second squared. And at all points, your force, pen kind of stinks, is equal to the gravitational force mg, your object's weight. Doesn't matter where you are, at the top of the path, your acceleration is still down, your weight is still down. Ask yourself, does the force of gravity go away? I don't think it does. So your weight definitely doesn't go away, and your acceleration does not go away. What does happen at certain points in the path is that there are changes in the object's velocity. So to break it down, we're going to look at a couple different kinds of projectiles. I'm not going to go over them now necessarily, but let's think about what happens. So at this point here, there is a transition of something. And we know it's not horizontal because horizontal is moving at a constant speed the whole time. It is in fact vertical, so your velocity vertically is equal to 0 meters per second at this time. For these, all the way up here, your vertical velocity is upwards. All the way down, your vertical velocity is downwards. A couple other things to note. For the max height, you want to shoot straight up. So the angle that we might measure from the projectile is from the horizon. So shooting straight up would be like a 90-degree angle. If you want to get max time in the air, you're also going to go at a 90-degree angle straight up. If you want to shoot for the max distance, though, for a given velocity, it's going to be at 45-degree angle. So 45-degree angle gets you a big, like a long shot, because it's got a lot of time in the air, but it's also got a fair amount of horizontal velocity. If you want the max horizontal velocity, you want to shoot at like a 0-degree angle. Not going to go anyplace because it hits the ground instantly, but you're directing all that velocity horizontally. It'd be like shooting it straight across the ground. If you want the max vertical velocity, you want to shoot at 90 degrees straight up. Then you're directing all that speed upwards. We will definitely see, I'm going to go through some permutations of this stuff, talk about some different kinds of problems that you might see. But for now, thank you very much for watching this video.